Find the current through RL. Actually, you can note down these numericals because this is not saved in my PPT, okay?
Okay.
To RL in the circuit of figure using Norton's theorem.
Ma'am, screen is disabled.
Okay, you can
Screen.
first you just disconnect and then you can connect. Then I think screen is the screen is visible?
No, ma'am.
No, ma'am.
Yes, ma'am.
No, ma'am.
No, ma'am.
No,
No,
ma'am.
ma'am.
No, ma'am. No, ma'am. No, ma'am.
No,
Okay,
ma'am.
just 1 minute.
No, ma'am. No, ma'am.
Just 1 minute. Now,
No, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
okay. So using okay, try to solve it. Find the current through RL in the circuit of using of the figure using Norton's theorem. Just try to solve it. After that, I'll explain.
Ma'am.
Ma'am, have you started Norton's theorem in our section?
Yeah. You was absent in the previous class.
No, ma'am, but we have not started in our
No, ma'am.
section.
Northern student is
Okay.
not started.
In previous class, I have already started Norton's theorem, right?
No, ma'am.
No,
No.
ma'am.
No,
You
ma'am.
are
No,
discussing
ma'am.
only
No, ma'am.
examples.
Thevenin's theorem.
No, ma'am.
Okay,
No,
previous
ma'am.
class I'm discussing about
No, ma'am.
Thevenin's.
No, ma'am. No,
Yes,
ma'am.
ma'am.
Yes,
Yes,
ma'am.
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay,
The
then I'm
example on
sorry,
7.
sorry, okay. So Norton's theorem basically states that a linear active network consisting of independent or dependent voltage source and current source and the various circuit elements can be substituted by an equivalent circuit consisting of a current source in parallel with a resistance. The current source being short circuit current across the load terminal and the resistance being internal resistance of the source network. Okay. So in case of Norton's theorem, it is basically similar to Thevenin's by how I'll explain. Uh, In case of Norton's theorem, again you have to first you have to shorted you have to remove the load resistance. First step, first you have to remove the load resistance, then you have to calculate the current flowing through this load, flowing through this short circuit terminal, that is short circuit current. How will you calculate the current? In case of Thevenin's theorem, this load terminal should be open and you have to calculate VOC, that is the open circuit voltage. So here you have to calculate the short circuit current. In case of Thevenin's theorem, as this circuit is open, that's why you are not considering this R2 resistance. But in this case, you have to consider this resistance also, because this one is short circuited. So this is complete loop. This is a complete loop. That's why you have to consider this R2. So now you have to calculate the total current of the circuit. So what will be the total current of the circuit? Can anyone tell me? This should be the total voltage drop divided by the total resistance of the circuit. So what will be the total voltage? That is the Vs, and the resistance of the circuit, that means these three resistance, where R1 is in series with these two and R2 and R3 are parallel to each other. So I'm just calculating the current I, that is Vs by total resistance. Now you have to apply the current division rule to calculate this ISC, because these two are parallelly connected. That means here if I current is flowing, if this one is I, then this one is I1 and this one is ISC. So I should be equals to I1 plus ISC.
मैम स्क्रीन नहीं दिख रहा.
अभी भी नहीं दिख
I'm
रहा
not
है?
getting anything, ma'am. Please repeat everything.
Ma'am, we are seeing everything. We can see everything.
Yes, ma'am, your screen is visible.
Ma'am, he
Say again,
is
ma'am.
outside.
किसको नहीं आ रहा है स्क्रीन?
Ma'am, someone has joined from outside. His name is Mrityunjay Singh. He's outsider. Ma'am, maybe he is trying to spam our class.
Yes, ma'am.
चला गया मैम.
I think he's removed.
Yes, ma'am.
He's
Yes, ma'am. He is removed, ma'am.
okay. So now screen is visible, right? Okay, so the total current is I and it's divided into two parts. That is, suppose this one, if this one is ISC, if this one current is ISC, this one is I1, or you can say I minus ISC, or I'm just telling you that these two are parallelly connected, right? So we can use current division rule. So here ISC equals to main current into opposite resistance, means this resistance divided by the total resistance. By that way, I can calculate the short circuit current, right? Next, we have to calculate the internal resistance. This is similar to Thevenin's theorem. You have to just calculate it from load end side. So Rn calculate from this side. So it should be R2 plus R1 R3 by R1 plus R3. And at last you have to calculate IL, load current. That is, again you can use, this is the equivalent circuit. Here it is ISC is parallelly, Rn is connected and RL is connected parallelly. So you have to calculate IL. So IL, again you can use current division rule. That means total current ISC into opposite resistance divided by the total resistance. Okay. So now I'll explain what is the relationship between Thevenin's and Norton's. Do you have any idea what is the relationship between VOC and ISC? Anyone have any idea what is VOC and ISC?
No, ma'am.
Okay, I'll explain. Suppose I'll give this one numericals. This one, okay. You have to find the current passing through 6 ohm resistor. So I'm explaining it. Just 1 minute. 44, 5 to 6. 40. 4, 5, 40 volt, 40, 4 to 5, so 4, 2, 5. Okay, suppose this one is given. And your question is that the find current passing through 6 ohm resistance. 6 ohm resistance. Your question, okay. So, in case of I am explaining both two theorems for Thevenin's and Norton's. So, for Thevenin's theorem, suppose I am using Thevenin's theorem. Here, you have to calculate the open circuit voltage. So, what is the value of open circuit voltage here? VOC equals to the voltage drop across this branch because this is open. So, 5 ohm is not considered here. So, voltage drop across this point is how much? It should
40
be
by 6.
40 by total resistance is 6 into 2, right? So, if we now consider the Norton's theorem, you have to shorten the circuit and you have to calculate ISC. So, now I am doing Norton's. So, here you have to calculate ISC, and for calculation of ISC, you have to find the first the total current, that means this current I. So, I should be here equals to 40 by the total resistance, that means 4 plus 5 into 2 by 5 plus 2, because these two resistance are parallelly connected. So what will be the value? 40 by 4 plus 10 by 7. This should be 4 plus 10 by 7. 5.43. 40 by 5.43. 7.37. So this should be 7.37. So what will be the value of ISC? ISC should be equals to total current into opposite resistance, means 2 divided by total resistance, that means 5 plus 2. That means 7.37 into 2 by 7. How much? 0.27 into 2 by 7. 2.10. Okay. Now you got the value of ISC. Now what is the value of RTH? Both cases RTH should be same. So I'm removing this and this. And for voltage source, it just shorted the circuit. I'm just shorting the circuit and calculating from this side. This is R int. What is the value of R int here? R int and RTH are both equal. I'm calculating from this side. That should be 5 plus These two are parallelly connected. So 4 into 2 by 4 plus 2. That means 5 plus 8 by 6. What is the value? 6.333. Right? And what is the value of this one? 80 by 6. It should be 13.33. Now, if we calculate ISC into RE, what is the value? It should be 6.33 into 2.10. The value is 13.3. So can you understand now what is the relationship between these two? VOC and ISC? Yes?
That is VOC.
Yes, that is VOC. So basically, VOC is basically ISC into RE. Okay, that is the relation. So when we consider this one, this is similar to, that means in this case, this is Norton's equivalent circuit, and in case of Thevenin's equivalent circuit, it is VOC is in series with Rin and then RL is connected. Right. So if the current source is parallelly connected with a resistance, then we can convert the circuit in voltage source with series resistance. That is the formula, because in a circuit, if we apply Thevenin's theorem or Norton's theorem or KVL, KCL, current cannot be changed. The current, suppose for this circuit, if in this branch, if 5 ohm is connected, 5 ampere current is flowing, then for Norton's theorem, the current cannot be 6 ampere. For Thevenin's current cannot be 7 ampere, right? So current always be same. So there must be some relation. That is I am asking. So in case of if you want to practice, you just do one thing. You just take a circuit. Okay, always take a circuit. Try to solve it using KVL first, then KCL, then use Thevenin's theorem, then use Norton's theorem, and check whether the answer is right or wrong. Okay. Okay. So I'm giving another example. So is this clear?
Yes, ma'am.
Yes, ma'am.
Okay, I'm giving one example. Okay, just 1 minute. So here is a circuit. This one is 5 ohm. It's connected across. Find the equivalent circuit towards the terminal X and Y. This is given 10 ohm. This is given 10 ampere. This is the top result. If this one is given,
Ma'am,
then
can you
find.
repeat the question?
Yes?
Can you repeat the question?
Yeah. Find okay. So what will be the first step? First I have to shorted the terminal. Okay. So this one is ISC. Now You can replace this circuit by this way. Right? I'm just rotate the clock, the circuit clockwise. So this 5 ohm is parallelly connected to 10 and 10 ohm and 10 ampere. So I'm just parallelly connecting it and I'm just replacing the node. That is, sorry, this one is X. This one is X and this one is Y. So is it clear to you? I'm just rotating this one. Or you can convert the circuit in this way. If this is 5 ohm resistance connected across, these two are parallelly connected, so we can convert it into voltage source with series resistance. So this one is 100 volt, is connected with 10 ohm resistance. This one is 5 ohm, and this node is X. This is Y. We have to calculate ISC. So you can do whatever you like. Both are equal. So what is the value of ISC here? For this case, you can use current division rule. So ISC should be equals to main current, that is 10, into opposite resistance, means 10, divided by total resistance, that means 10 plus 5 means 15. In this case, you can apply KVL. Here the current is ISC flowing, so you can write 5 ISC minus of 100 plus 10 ISC equals to 0, or ISC equals to 100 by 15. Is it clear to you?
Yes, miss.
Okay. So now you have to remove, for internal resistance calculation, you have to remove the resistance. So I'm removing this, you have to remove the sources, all sources. So for both cases, I'm removing the sources. So now this one is my circuit and also this should be open. Just a minute. So this should be open and this one should be open. For both cases, you can calculate the internal resistance. What should be the value of internal resistance now? Rint is what?
15
How
ohm.
much? Yes.
15.
Because this is directly connected in series. So Rint should be 15 ohm. So now you should make the equivalent circuit there. Here ISC is 100 by 15, that means 6.67. So you have to draw the ISC which is equals to 6.67 ampere. Next is connected Rint which is 15 ohm. It's connected, and then XY terminal it's not given. So this one is X, this one is Y. This is my equivalent circuit. So is it clear?
Yes, ma'am.
Okay. Then try to do the next example. This one, these two. This one. Try to do this one. In the circuit of figure, if R1 equals to R2 equals to 4, find the short circuit current through X1. So in this case, this R2 is given 4 and R1 also 4. So what should I do first? And I is given. Just a minute. I'm not giving the I value. I can't. Yeah. I is this one current. This one is I. Okay. So in the circuit, if R1 equals to R2, so first you have to shorted the circuit, right? ISC. So first you have to calculate the value of ISC. So you can apply KCL here. All branches current are given. So we can write 2 plus 2I equals to I plus ISC, or we can write 2 plus I equals to ISC, right? This is my first equation. So if now we can apply KVL in this loop, this is A, this is B, suppose. So we can apply KVL in A, X, Y, B. So what should be the equation of KVL here? So in case of KVL, we can write 4I minus of 4ISC equals to 0, or we can write I equals to ISC, right? Is it clear?
Yes, ma'am.
So now these are two equations. One is 2 plus I equals to ISC, another is I equals to ISC. Is it possible?
No.
So this solution is undefined. So next case. In the next case, R1 equals to 2 R2. So now you can put R1 equals to 2 R2. So first KVL equation we can write R1 into ISC minus R2 into I equals to 0. Here R1 equals to 2 R2. That means we just replace R1 into 2 R2. That means 2 R2 ISC minus R2I equals to 0. Or we can write 2 ISC equals to I. If we put this value here in the first equation, then we can write 2 plus 2 ISC equals to ISC, or ISC equals to minus 2 ampere. So if the second condition is given, R1 equals to 2 R2, then ISC equals to minus 2 ampere. Is the numerical is clear?
Ma'am, why we could not solve using equation number C?
Equation number 2 and equation number 1, in the first case, both two conditions cannot be satisfied. If 2 plus I equals to ISC, then I cannot be equals to ISC, right? So this
Yes.
solution is undefined. This one is for condition 1. And this one is for condition 2. Is it
Okay,
clear?
understood.
Okay.
Yes, ma'am.
So this condition cannot be satisfied because these two equations are not solved, cannot be solved. So we again use this equation. If R1 equals to 2 R2, then we'll get the equation and we'll put this value here in the first equation. So we'll get that ISC equals to minus 2 ampere. So if R1 equals to 2 R2, then ISC equals to minus 2 ampere. So is it clear?
Ma'am, I didn't get your point.
Which
Ma'am, I
one?
didn't get your point.
Tell
Ma'am,
me.
last two lines of the last two line of the condition number second.
This one, these two.
Yes, ma'am. Yes, ma'am.
This one equation you got this one equation you already get in the previous condition. 2 plus I
Yes,
equals
yes,
to
ma'am.
ISC.
Yes, ma'am.
I'm
I
just
got it,
putting
ma'am.
the value of I here. I equals to 2 ISC for second
Oh,
condition. If
okay,
R1
ma'am.
equals
Got
to
it.
40, I'm just putting the value here. So ISC equals to minus 2A.
Yes, ma'am. Thank you.
Okay.
Yes, ma'am.
Okay. So try to solve this one. Find the current through RL in the circuit of figure using Norton's theorem. So what we'll do first? First, you have to remove this RL. So the circuit is just look like this. Three I0. This one is I0, 6 ohm. This one is 12 volt. This one is 3 ohm. And this is X and Y. It's a shorted ISC. We have to calculate, right? So, tell me one thing. If there are two branches are connected parallelly, these two branches, this one branch and this one branch are connected parallelly, right? So, is there any current flowing through this branch?
No, ma'am. It will be short circuited.
Yes. Current always try to flow from the shorted resistance path.
Yes, ma'am.
So, this there is 3 ohm resistance and this one is shorted. So, all total current will pass from this path. So, this will eliminate it. So, if this one is shorted, then 3 ohm should be eliminated. So, I'm eliminating this one. Now, you can use easily the for I, we can write here I0 plus 3 I0 should be equals to ISC from the equation,
Yes, ma'am.
right? Now, what is the value of I0? If the total voltage drop is 12 volt and total resistance is 6 ohm, then what is the value of I0? 12 by 6, that is 2 ohm, 2 ampere,
Yes, ma'am.
that is 2.
Yes, ma'am.
So if we put this value, then what is the value of ISC? 4 into 2, that means 8, right? Now, you have to calculate the internal resistance. So always remember that I am already telling you in Thevenin's theorem that if there are dependent sources given, then you cannot calculate it by removing the source, right? So in that case, you have to calculate the VOC, because we know that VOC equals to ISC into R int, right? We know that VOC equals to R int into ISC, right? So if we want to calculate R int, then we can easily, R int should be equals to VOC by ISC. So we can, if we calculate VOC, then we can easily find R int, right? So again,
Yes, ma'am.
here we just connected this 3 ohm resistance. 3 ohm, and again we have to remove the short this part, and you have to draw all the circuit in each step. Okay, so you have to calculate VOC here now. So what will be the value of VOC? You can take any node. Suppose this node or this node, I am taking here had VOC. So we can write. We can using first we can easily write that I0 plus 3I0 minus of VOC by 3 equals to 0, right? Because these branches, these 3 ohm resistance branches are parallel to VOC. That means the voltage drop across these branches should be equal to these branches, right? So now, what is the value of I0? I0 means we can replace I0 by 12 minus of VOC divided by 6, right? If this node is considered as VOC, then we can write 12 minus VOC by 6 plus 3I0. That means 3 into 12 minus VOC by 6 minus of VOC by 3 equals to 0. So is there any doubt? Any doubt?
No, ma'am. No, ma'am.
Then you can easily find the value of VOC. So I'm telling you already it's 2:30. Another classes will be started. So here VOC, you will find that VOC is 8 volt. Okay. So then you can calculate easily Rin. Rin should be equals to 8 by 8. That means 1 ohm. And then you have to draw the equivalent circuit. The circuit is just look like this. This one ISC is 8 ampere is connected across 1 ohm, that is my internal resistance, and the load resistance is 1. So this one is also 1 ohm, and you have to calculate the load current IL. So by the formula you can use IL should be equals to ISC, that is 8 into opposite resistance means 1 divided by total resistance, that is 2, that means 4 ampere. So is this clear?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes, ma'am.
Okay, so your next classes will be on Monday, right? Monday or Wednesday?